Hi, my name is Pablo Brusco, and today I want to talk about this project in which we try to solve the problem of predicting the sentiments of a given utterance in a voice conversation. As many of you know, there are at least two main approaches to tackle this problem. The first one is a two-step approach in which we transcribe the audio using an ASR system, and then on top of that we train or use a sentiment classifier based on text. And the second approach is an end-to-end approach in which we try to predict the sentiment directly from the audio. The problem with this approach is first the lack of annotated voice sentiments data. So the initial question we have is if we can reduce the human supervision significantly by leveraging a large amount of data without human annotation. And for that, we will propose a pre-trained language model as a pseudo-labeler in an end-to-end approach. Second, we also are interested in measuring how much the possible ASR mistakes affect a two-step approach system in this case. So the first experiment is based on comparing two different end-to-end models. The first one, the baseline, in which we have an ASR audio encoder from which we will get the representation of the audio, and on top of that train a sentiment classifier. And the proposed approach, in which we have a pre-training stage and a fine-tuning stage. In the pre-training stage, we will use a large amount of unlabeled speech data, run an ASR on top of it, get the text, and then use a pre-trained language model such as BERT SST2 that will predict some sentiment labels. In this case, we will use those as pseudo-labels for warming up this sentiment classifier. What we see in the results is that the use of a pre-training stage improves the quality, the performance of the model, but also it makes it much more robust when we reduce the amount of training data from 85 hours into 5 hours. Also, we have an additional experiment in which we show that using only a third of the dataset makes us achieve the same quality of the baseline model. The second part of our experiments show how we can leverage the use of a pre-trained language model in a two-step approach. In this case, the two-step approach consists in having the audio, running an ASR on top of it, and get the text, so that then we can train a text-based sentiment classifier. In this case, we see how the pre-trained language model helps increasing the performance of the system. But in particular, when we switch from human transcripts into ASR transcripts, both for training and evaluation purposes, we see that the baseline model drops significantly. But the model based on the language model is much more robust to those changes. As a final experiment, we measure how much the performance of the system decreases if we only use 5 hours of training data. So that's all. I hope to see you all in the virtual sessions. Thank you very much.